Good morning, everyone. Thank you for joining us for this webinar, where we will be discussing how to light a sports environment. My name is Nadia Smith. I'm BEKA Schréder's Senior Communications Officer. Please note that we will be recording this webinar and will upload it to our YouTube channel. As we are sitting in various locations to present this to you, please excuse any external noises. For any specific questions, we will have the Q&A session after the presentation. So let me quickly take you through our agenda for this morning. I will be giving a brief introduction about BEKA Schréder. Grant Combrink, our Marketing and Segment Development Manager, will talk about our OMNIBLAST-E floodlight range. Rian Bab, one of our Senior Sales Engineers based in Cape Town, will talk you through application requirements. Retief Kutzer, our Applications Manager, will explain the more technical side of things. And Dani van der Nest, our expert in smart systems and solutions at BEKA Schréder, will talk to you about our stadium control system. So let me introduce BEKA Schréder to you. BEKA Schréder is Africa's leading manufacturer of luminaires and GRP poles and has been established 44 years ago. We manufactured our first LED luminaire in 2009 and have not looked back since. We export into sub-Saharan Africa and the Indian Ocean Islands. For those of you who don't know about our history, BEKA Schréder started operations in 1978 in Namibia, a country that is one of the most corrosive climates in the world. The first products to manufacture were corrosion-resistant GRP poles and public lighting luminaires that continue to provide long-term solutions for the hostile coastal and inland environments. Due to the success of our products becoming firmly established in neighboring South Africa, the decision was made in 1981 to move the head office and factory to Olifantsfontein in Gauteng. Since 2002, we've had a partnership with the Belgian company Schréder, a multinational lighting company that is present in about 35 countries. In 2013, we became a wholly owned Schréder company, allowing us to continue to deliver the highest levels of service and the best global lighting innovations available in the market today. We as BEKA Schréder, being a local manufacturer, believe in sustainability and contributing to the economy and local communities. Our latest audited BBBE rating of level 3 shows our commitment to support transformation, development and growth. We became South Africa's first lighting company to be awarded ISO 9001 certification, and this commitment to quality became the company's hallmark, enabling us to become Africa's largest lighting manufacturer and market leader in exterior lighting. By combining the best of LED technology with a wide range of control systems, our solutions can offer huge energy savings of up to 85% and radically reduce the payback time of a new installation. Our success can be attributed to the research and development of our luminaire and pole ranges, ensuring the appropriate mechanical and thermal product integrity in the environmental conditions of the African continent. Since the beginning of the year, Daniel Casper is leading the company as General Manager as BEKA Schréder. I'm now handing over to Grant, who will talk about our OMNIBLAST-E floodlight range.
Thank you, Nadia, and good morning to everybody. Just a quick overview of our OMNIBLAST-E. We're very proud of this product and we're really going and pushing into the new generations of this with regards to performance up. First of all, you can see that we've added to our MIDI range, a version that you have a 3E now. So we're really giving you as the customer and end user and specifier a lot more options with regards to wattage, lumen output, and versatility with regards to your application. So just first of all, as I said, with regards to versatility, this product can be used anything from general floodlighting all the way through to specifics now with sports. So now we can go into a little bit more detail into the product. Just some of our key advantages. Obviously, the quality of design. We really pride ourselves at BEKA BEKA Schréder with our R&D department. We really take pride in that and really trying to lead the market with regards to new product innovation and really driving the market hard to get the best possible solution to the customer. This product also very efficient, really driving a mixture between performance and versatility with regards to that, as mentioned before. The big thing here is that we really want to meet the International Sports Federation standards and regulations with these products, especially with regards to any TV solutions. I just want to carry on there. Yes, so here you can see specifically we do focus on any broadcast or any specific camera positions with regards to design, which Retief will go into a little bit later. And really the flexibility of that, so that you can really have a full solution to do a replacement of a 2000 watt or 1 or 2 kilowatt HRD lamp. And again, a big advantage for us is that this is locally manufactured. We really pride ourselves in that because we've got the factory, the R&D department and that, so we really pride ourselves with our local manufactured product. Thanks, Nadia. Just into a little bit more detail, the high pressure die cast aluminium, we really pride ourselves in our materials from the housing and the mechanical side of the luminaires to make sure that this fits into any specific environment, whether it be corrosive or not. And then we are able to back that up with our 5-year warranty. We do look at the most cost-effective solution for brown and green buildings here. Yes, depending on the usage, that'll also be dependent on the maximum energy savings that you get. And also with regards to this, we designed as a future-proof option where we can look at upgrades, performance upgrades, anything from a control gear option to a chipset option. Obviously, you all know one of the main benefits with LED is the instant on and off, and also the dynamic options that you do have to create any effects. And Dani van der Nes will go into that a little bit later with our control system. Inclination, angle, and aiming and commissioning is done on site, and this gives you the flexibility to be able to do that with aiming, and we will definitely assist with any commissioning and aiming that you do have on your sites. We have to protect ourselves here with the product, as we do know we have some of the power grid issues, so we definitely make sure that there's protection. And then in the MIDI version, we do have our zone 2122, just for more industrial explosive environments that we're able to accommodate there. I just want to quickly go through this, so please feel free to download our brochure for more details, just to show you here our typical luminaire output flux. So I'm going to highlight the luminaire output flux because that's really what we want to achieve, because it's important here to focus on what you're actually getting on the ground, not necessarily what's sitting in the chipset. So it's all about the efficiency of this unit. So for this unit here, we've really we've upgraded this, so it's pushing out about. Can someone just mute the? Hold on, let me just mute there. Sorry about that. We're able to push out just under 55,000 lumen on this unit, really powerful, sitting at about 412 watts. Nadia, do you want to go to the next slide? Here on the 2-head version, we're pushing way over 100k lumen, almost basically a 1 kilowatt replacement. Nadia, do you want to go on there? Here with the 3-head version, you can see by the lumen output, they're really giving you versatility to be able to do easy 1-for-1 replacements with the HRD you have at hand. Then on the maxi version, slightly higher output and wattage range. You can see here we pushing 80 up to 80, just over 80,000 lumen. Mute there again. Sorry, please just make sure you mute it on there. Thank you. On the 2-head version, again, we're really pushing the lumen output here, and I'm going to go into the optics a little bit more just now. On the 3-head version, Nadia, you can see we're really driving this product to really be as efficient, as powerful as possible with regards to large stadiums. You can see by the lumen output there, it's really driving the market with regards to performance on this unit. Okay, next slide. As you know, historically we are renowned for our optical solutions coming from the past of the HID reflector systems, and here we have part of this range. You're able to look at a LensoFlex 4 or 4th generation LensoFlex optic here. This is a huge advantage to us, where we're really driving to make sure that you get an optimized light intensity and light distribution from your unit. This also gives us an option now where we've actually looking at miniaturization, where you can actually downsize the unit and get more power out of it, because the chipset is obviously placed slightly closer together and gives you more options and flexibility around your optics around that. Another advantage for us, we really look at collimators. We really want to drive the peak of our light distribution and the candela per kilolumen. So this really allows us to really look at those directional type beams. So we really have an advantage in the market over competitors with regards to this and the development of our optics. Yeah. Just some more detail on some of the optics you can see from the polar diagrams here. And please just look at the brochure for some more detail. You can really see we're driving on the peaks, and we also have the asymmetrical and specific beams for sporting application and floodlight application. So please have a good look there and consult us accordingly with regards to the design. So we really have some flexibility around that to give you the best uniformity with the design calculation. Thanks, Nadia. Okay, I'd like to hand over to Rian. Thank you.
Hey, morning everyone. Thank you, Grant. So yeah, basically when we need to do a lighting design, there's a couple of information that we need to gather. Nadia, just the next slide there, please. So we do an audit. Now, why do we do audit? So to define the problems and requirements and offer the best adapted solution to a specific sports environment, and then to collect the essential information for the lighting study. Next slide. So we have a checklist that we compile so that we can gather all the necessary information to enable our designers to do a comprehensive design. First, we need to see, is it an indoor or outdoor installation, and for what type of sport it is. Is it rugby, soccer, hockey, tennis? Then when it's a new installation, we need to determine possible mast positions, recommended mounting heights of the mast. Should the project be a retrofit installation, then we require the existing mast positions, obviously, and then the mounting height as well. And the layout of the head frame is also important. For both indoor and outdoor designs, we require the length and the width of the field or pitch or court if it's an indoor installation. And if it's an outdoor sport, indoor sport, the color of the walls is very important, as we know that different colors has different reflection properties. What is the required luminance levels? Do you need 100 lux, 500 lux televised broadcasting? Uniformity levels required, horizontal and vertical ratios are important. And then what is the maximum level of glare that is allowed? Is there any key information to take into consideration for the luminaire choice? If it's a retrofit, basically the size of the luminaire plays a big role. If you have a existing head frame, the floodlight that you look at might be too large, and then you need to maybe look into using a smaller floodlight. What is the required color temperature and your color rendering index for the sport? What is the televised lighting consistency index? This is only for HDTV. And then obviously for your televised broadcasting, it's important to know the camera positions and the height of the cameras. That is quite crucial for the designer to know that information. And then fixation of luminaires. Is it installed on walls, what type of surface, slabs, or is it maybe suspended? What lighting requirements for the surrounding areas and grandstand needs to be taken into consideration? It might be an outdoor sports field that's situated in a residential area where we're required to keep the light spill to a minimum. So it's also important to know that. Okay, Nadia, next slide. Then this is a sports lighting level table from Sankey that can be used as a guideline to illuminate different sports disciplines. There are other documents available as well that can be used as a guideline. For example, if it's a soccer field, you can use a FIFA standard document. There's also other documents for hockey and tennis and so forth, but this is a very good guideline to use, especially if the customer doesn't necessarily know for what type of lighting level they want to go for. I will now give over to Retief to talk a bit more about the design. So obviously once we gather all this information, we will hand it over to our applications department where they will then start off with the design.
Thank you so much, Rian. Welcome everyone. From here in South Africa and the greater African continent, and then anyone who might be abroad. It's a pleasure for us to host this or to have you, and then to expand a little bit on sports lighting. In general, this is a very general overview touching on, I think, the most important parts to be considered when designing and when providing our clients here and abroad on with a solution that is optimal based on either what they've described as optimal or on the recommended standard that they've required us to design according. I'm going to very quickly touch simply on two metrics, illuminance and luminance, as there is a difference, and I think in many cases, there's a misunderstanding regarding visual understanding between these two, and specifically in sports. I'll then touch on glare in sports, specifically glare in outdoor environments, not unified glare rating, but glare rating. I'll touch on uniformity, the different types of uniformity, the two main types of uniformity that we generally calculate for, and then for higher levels of play, like FIH hockey standards or FIFA or UEFA, the types of uniformity that you could potentially consider. I'll very briefly explain color rendering index, and we'll go through a few examples and then a little conclusion. So it's going to be a very laid back, hopefully clearly understandable discussion. So if we can go to the next slide, please, Nadia. Thanks. So why do we perform a sport lighting study? You can let all the bullet points come up. Thanks, Nadia. Is to comply with relevant standards, regulations, and recommendations by those authorities that have done the relevant research into the specific sport. For safety and comfort and enjoyment, and this is for safety and comfort and enjoyment of all participants. It's not purely for the sportsmen who might be taking part in the sport, but also for those spectators at all levels, ground level, and if there's if it's like a stadium with seating at various different locations in the Z-axis, for those, and then again for the comfort of the television audience if broadcasted as Rian rightly mentioned earlier, we need to take a few things into consideration with regards to vertical illumination. We then have to realize the simulation and find the most cost-efficient and optimal lighting solution, and that would be something like making sure we use the lowest mast positions possible, the fewest luminaires with the best optical solution, the best types of beam spread, in order to achieve what is required. Grant touched on some of the optics that we have available, and generally for this type of installation, you'll break down your beam spreads in two categories. You have your collimated beam categories, which are your focused beams, basically your extra narrow, narrow, medium, and wide beams, which are basically columns of light exiting the luminaire, normal to the luminaire, and wherever you aim that luminaire, that's where the highest intensity of flux can be expected. Then you have the other side, which is your asymmetrical floodlight type optics, where or distribution, where your luminaire is facing the ground, nadir, and its peak intensity is at an angle being emitted from the luminaire. We have various different optics, and something I might try to explain it this way. If the luminaire is facing the ground, so the flash area is facing the ground, or the luminous opening is facing the ground, the highest peak intensity in a collimator optic would be right below the luminaire. But with that kind of beam distribution, it would be cast forward away from the luminaire at various different degrees, 60 degrees, 65 degrees, depends on how we designed or how R&D designed the luminaire, as well as the optical, how the optic was designed by Schréder. We then have to simulate the lighting pollution. I say we have to, it's dependent on where this sports lighting installation is, whether it's in a protected area. We do take into account the spill, as it's good practice, but if it's in a built-up area, we take it very seriously, and then we measure the extraneous light or the spill into the adjacent neighborhood, specifically those residences or businesses that might be affected, typically across the street from the stadium. Generally, if the stadium has a roof, there's not really any spill, and noise becomes the biggest problem. If it's not a stadium, an enclosed stadium with a roof structure, and it's purely masts, then this takes precedence, and we start really narrowing in or zooming in onto the spill light calculation. And then obviously, once we've finished the design, we would send it back to our relevant sales representative, who is in contact with the client, and the sales representative would prepare a quote based on that design. Next slide, please, Nadia. And you can bring everything up. So all of those criteria are important when lighting a sports environment, amongst other parameters that also need to be taken into account. I'm going to try and touch on everything today. And this is why we always perform an audit and a lighting study of each sports environment that we illuminate. Now, what is meant here by an audit is exactly what Rian Bab touched on. While they visit the client, or while they go and visit the area to be illuminated, let's use a soccer field or a football field, for instance, they would, if there aren't any existing masts, they would, I guess, discuss budget with the client, lighting levels, explain the difference in luminance and illuminance, and potentially, I think a lot of people don't understand the visual impact that if I said 20 lux, what that means visually, or 100 lux, what that means visually, and how it's translated into the visual spectrum, which is measured in candela per square meter. Where you actually have the sense of vision. They would do an entire audit, a good profiling of the client, and find out, basically like a good server in a restaurant, how are they, how is this meal really going to be enjoyed by the client? and that would be sent to us. I like to compare an applications department to a restaurant, and we are the chefs here designing or creating the really good dish as briefed to as per the briefing that's provided to us. And yeah, that's it. So then we would create that. We would carry on with creating the meal. So if we can go to the next slide, please, Nadia. Pardon me. All right, so here these were just two nice images. The one on the left, I think, was quite comical. And it's also good to give blood if you can. But what you're seeing in front of you right now, you are not seeing lux. The eye cannot see lux. Lux is a measure of illumination arriving at a surface before it's interacted with any matter and have whether it's been reflected. Once it's interacted with matter, then you can see. So potentially, I'm sure most of you are watching this presentation on your screen, and between yourself and the screen, there's actually quite a lot of flux potentially, and you cannot see that, but it is there, and that's why you can see the screen. Well, I say that screens are internally illuminated, but that's why you can see your walls, is because the emitted flux from the luminaire has interacted with the wall, with the matter, the physical properties of the wall, and it's been reflected, and now you can see, you have the visual sensation of sight. And that's measured in candela per square meter. And a lot of people generally would say, I want 300 lux, but they don't understand how to interpret that visually. And right at the end of this presentation, I think there's going to be some examples of stadiums, and once we get to the Petersburg High School Astro Hockey field, please remember that what you're seeing there is 100 lux. Well, I'm saying you're not seeing 100 lux, but the design was, the requirement was for 100 lux. We got about 114 lux with very good uniformities in the U1 and the U2, very low glare. So once we get to the Petersburg example, just make a mental note. What you're seeing there was designed for 100 lux. I did a very rough calculation, and that should be in the vicinity of about 8.5 to 9 candela per meter square, which is what your eye is actually interpreting as brightness. Okay, so that's a very quick, simple the distinction between illuminance and luminance. Illuminance can't be seen but can be measured. Luminance can be seen and is what's seen and can be measured in two different metrics, lux or candela per square meter. All right, so let's carry on to the next slide, please, Nadia. All right, so first things first, you can bring up all the slides. Thanks, Nadia. What you're seeing here is an example of horizontal illuminance. Horizontal illuminance is the flux density per unit of surface area, and this metric expresses the amount of light incident upon a surface, or I think a better terminology is arriving at a surface. So it's arriving, it hasn't done anything yet other than arrive. It's not interacted with anything. What you're seeing to the right of your screen are the masts placed around a astro hockey turf, and with their aiming angles or aiming vectors onto the field, with a 5x5 meter grid at ground level. I know some people might ask, why are we designing at ground level when most standards require us to calculate at 1 meter above ground level? And the quick answer is, if you take into account the inverse square law, if I get 100 lux at ground level, I'm going to get a higher lighting level 1 meter above the ground, as the surface has now moved towards the source of emitted flux. So at BEKA, we like to under-promise, over-deliver, but not to the detriment of the client with regards to we're going to put 100 luminaires just to make sure we get that lighting level. We like to work optimally, place the calculation plane at ground level in order for us to ensure the lighting levels that will be measured at 1 meter above ground level facing the sky, so the horizontal plane, will definitely achieve what is being what was required. On the bottom of that slide, you'll see a plan view or an elevation view or a cross-sectional view, just showing how we do in many or in most cases try to space the luminaires so that they do not interfere one above the other and shine into the back of the luminaires below. And we then also would space them longitudinally or away from each other in the vertical plane in order for, well, taking into account the rotation or the orientation in the azimuth of the luminaire, taking into account the aiming angle. Another thing that I think might come up is some people might ask, yes, but there shouldn't be luminaires cross aiming on certain masts on the same head frame. Yes, this is correct, but every scenario is different. Most of the time that is the case, but in certain cases the briefing or the limits presented to us dictate what we need to do, and then we need to make the best of that option so that we can provide the client with the best solution for their specific, I want to say tailor-made and individual case. All right, Nadia, we can move to the next slide. Thank you so much. So this is it's a very simple graphic. It's not at all technically correct, but it does prove the principle or show the principle. When you have a look at the mast, you'll see I've positioned four little images looking like that are looking like luminaires facing the sky. Sorry about that. But what I'm trying to indicate there is, in most cases, we try to, and it's also good practice, to work from the bottom to the top using the widest beam at the bottom of the mast, moving up to the medium beam, then the narrow, then the extra narrow, or the narrowest optic we have in our basket of products, and then aiming them at the correct areas on the field, so that we can obviously increase intensity, get to their correct lux level, but also to ensure good uniformity. That's all that little graphic is indicative of. So I've touched on horizontal illuminance in the slide before this one. This is the calculation plane that's on the ground or 1 meter above the ground, looking into the sky and measuring the incident flux on that plane. If you go on to the next slide, please, Nadia. You'll see a little image I drew to try and explain vertical illuminance. The vertical illuminance is important where cameras are present. Rian Bab touched on this. Televised broadcast, high definition televised, slow motion. This is where vertical illumination becomes important. And also in certain sports, even where there's no televised illumination, where there's no television or no broadcasting is required. Hello? Sorry?
Hi?
Did someone say hello?
Yeah, now I can hear you. Okay, this pole, this pole. What are we supposed to do there?
Sorry?
Sorry, Sadesh, can we pause and get the Q&A at the end, please? Sorry about that. We just want to be able to get through that, and then we'll come back to your question, if you don't mind.
To get all of someone like Guy Merkel.
No, I think you're at the wrong company, sir.
Look, the Tequini pole, the council pole, the streetlight pole, that's about 10,500 Rand supply.
I'm going to mute Sadesh.
Yeah,
because I think he's actually on a phone.
I've just muted him. Okay.
All right. So to carry on, there are sports. Oh, no worries, no worries. There are sports where vertical illumination, I think, should also be considered as reasonably important. Sports where you have projectiles traveling at you at speeds where there's a higher risk of injury. Tennis, cricket, baseball, anything where something is, I think, purposefully pitched, thrown, might be hit at someone, and there's the potential for injury. I think vertical illumination should still be taken into account, just as a matter of good practice. Again. So this is the image that you're looking at is showing, first of all, horizontal calculation plane above ground level, but with the colored lines, I've tried to indicate that those angles that you see are specifically aimed to a point in the X and Y axis, but also in the Z axis, aiming at the center of the lens of the expected camera equipment that's going to be broadcasting what it's seeing. And this is a very important metric in televised sports. So I just thought this is a nice way to show how a vertical calculation plane is created over the entire field for specific sports. I'm not going into all the sports and how we do it, but then of course, when you have FIFA recommendations, for instance, there are set camera positions, but it can go all the way up to, if I'm not mistaken, all the way up to 38 camera positions at various different angles and heights above ground level. And then we would take those into account and to achieve the vertical lighting levels required by that relevant standard, as I mentioned in one of my earlier slides. And that is a quick and simple definition or distinguishing between horizontal and vertical illuminance. If we can move on to the next slide, please, Nadia. Thank you. So I've just tried to highlight or reinforce what I've just mentioned in the previous two slides. This is obviously, you can see the tennis court, the playing area, the blue area is basically your horizontal calculation plane. And then the net would be typically where you could either see that's the light that you're seeing there is basically seen as a vertical plane because it's vertical to the horizontal. And that's just a very simple explanation. All right, if we can go to the next slide, please. All right, so glare. In 1994, the CIE developed a glare evaluation method for outdoor sports lighting and area lighting applications in CIE document 112 from 1994. This system is available for checking the glare rating situation of existing installations and for predicting glare rating at the design stage in new installations. The glare rating is the glare rating calculation grid provides an indication of glare experienced by the observer for each point in the grid based on the veiling illuminance produced by the luminaires and the environment on the ground plane only. On an observer's eye. It is measured as the observer looks at each point on a horizontal illuminance grid. And then very important, glare rating is restricted to horizontal grids of points below eye level and is used in outdoor area and sports lighting applications. A lot of people might be under the impression that glare rating is taking into account the glare experienced when either standing straight on the field in various positions, looking forward and up, which is not the case. It's actually the opposite. It's looking forward and down, and then taking into account the veiling luminance into the eye, and that's what glare rating. That's why we use glare rating, and that's how glare rating is calculated. If you go to the next slide, Nadia, I just think it explains it a little bit better. So what I've tried to indicate here is the person standing on the field, the potential observer measuring glare, according to the CIE 112 document, 1994, and the person is now facing, let's say, along the field. If you'll just switch on the next animation. Thanks. You'll see there I've drawn a line going through the eyeball, facing forward, and all the points below that observer. And that observer, wherever we've placed these, well, there will be many observers. Each observer will be looking forward and down at each horizontal calculation point in a 360-degree azimuth, and then calculating the maximum glare rating value to figure out, or to then determine what the glare, the potential glare is that they might experience. Glare is measured, or glare rating is measured as a maximum, so it is the maximum value that we are interested in, not the average and not the minimum, where UGR is obviously the average. But I'm not going to go into UGR now. All right, so that's basically how glare is calculated in outdoor sporting environments. It's a function of the veiling luminance entering the eye as measured by an observer looking all around them in a 360-degree rotation, looking at each horizontal point from eye level to down to each horizontal point. All right, and if we then go to the next slide, please, Nadia. And until everything is on the screen. There we go, thanks. All right, so glare control. This is the maximum CIE glare rating, and this is a really nice little table to understand. Most installations, we wouldn't want to provide a design with a glare rating higher than 55, and 55 GR would be typical of any kind of very low level or training type activities. Generally, we try to work for below 50, and then in certain high level sports where you have professional players, this is their bread and butter, this is their income, this is how they feed their families, as well as the risk that's posed to them. A GR of 40 or less is required as a maximum. Something to take into consideration: the two images in the center of your screen showing the two 15-degree arcs going from the center of the goalpost. Those are out of the UEFA document. The one on the right, where you have the additional 20-degree on either side of the corner of the field, is out of the FIFA document. And these are areas where we are not allowed to place floodlighting. However, as I mentioned in the previous slide, in some circumstances, there are physical limitations where masts or luminaires have already been placed, or they're only allowed in these areas. There's no way we're going to be able to, or we're allowed to suggest other positions. And then you'll see in the center image that if that is the case and there is no other way to illuminate this area, the luminaires that are in fact within the no floodlight zone should be taken careful consideration and aimed outside of that penalty box area. Only the luminaires that are outside of that total 30-degree arc are allowed to go back into the penalty area. And again, you might see that where it says luminaires focused inside penalty area, the luminaires to the furthest, to the bottom of that arrow will generally be facing the furthest away, because they'll most likely be your narrower beams. And as you get closer to the end of the field, we'll start looking at wider beams, which have lower peak intensities and a better spread, which assists in us getting to those different types of uniformity. And to minimize glare, again, that's why those positions are there and recommended to be used, so that the sports person on the field doesn't experience any kind of detrimental glare or a glare that's not allowed as per the recommended document or standard. So we exclude luminaires from those critical areas. We mount luminaires above a specified height. Generally, luminaires shouldn't be below 25 degrees from the center of the field at a specific angle, and no higher than 45 degrees. This is again the requirement. And also, there's a recommendation that luminaires shouldn't be aimed higher than when the luminaire is being raked. It shouldn't be aimed or raked higher than 70 degrees. Again, this is a recommendation. It's not necessarily always the case in all cases possible, but that's why the GR calculation is so vital, so that if there are luminaires that are raked above 70 degrees from nadir, as long as the glare complies, then we're happy to carry on with that. And then obviously to select an appropriate photometric distribution, which I mentioned earlier. We can go on to the next slide now. Thank you, Nadia. All right, so uniformity. There are a few different types of uniformity that we take into account. Generally, it's overall uniformity and the minimum to maximum ratio. As you can see in this image, you've got spots of very high intensity that very quickly taper off into dark areas, or areas that are dark relative to the areas that are bright. And this is terrible uniformity. This will not do. So in sports lighting, generally outdoors, we take into account the overall uniformity, which is the uniformity of the spread of flux arriving at the surface. That is, and we generally have to have that quite high. I would say, 60 to 70, even higher percent uniformity in the overall uniformity, depending again on the requirement of the client as well as the specified standard, if something has been specified. And then your minimum to maximum ratio, or your also known as U1. This is the ratio between the highest measured or calculated lux level on the horizontal field, on the horizontal plane, to the minimum, the lowest calculated lux level on that horizontal plane. And again, this is what's going to give you that visual impression of bright to dark. So we want to really be above 55, 60% on the minimum to maximum ratio, or the U1, in order to have a really good distribution on over the entire field. And again, it's a quick way to measure not how smooth, but how quickly it will go from bright to dark, or where the worst area is, and then provide that solution to the client. There are other uniformity, types of uniformity we take into account, like coefficient of variation or uniformity gradient. The FIFA document says you can use either or. And basically the difference between coefficient of variation and uniformity gradient is coefficient of variation is measuring typically the smoothness of the distribution of the light, of the visual impact on the observer, where uniformity gradient is measuring the fall off on adjacent points from a center point over the entire field. So it's actually what the coefficient of variation measures the mean, and the uniformity gradient measures the maximum non-uniformity, if you like. All right, next slide, please, Nadia. This is yes, please, thank you. This is a very simple indication in pseudo-intensity diagram, or in false colors, to show the different intensities. So you'll see field 1 correlates to row 1, field 2 correlates to row 2, and field 3 correlates to field 3 to row 3. So you'll see they're all in the 135 range, kind of lux average, 135 lux average range. But you'll see there's quite a big difference between the minimum and the maximum illuminance values, as I've just mentioned before. So you'll see they all have, I would say, decent overall uniformities, but those minimum to maximum ratios are quite terrible, even in the case of field 3. However, out of the 3, I would choose field 3, purely because the ratio between the minimum measured or calculated lux level is much to the maximum calculated lux level is much smaller than the ratio between fields 2 and 1, and visually that would have an impact very much like the slide where you saw those spots of flux, or those spots of luminance on the ground. And this is the importance of at least having your U2 and your U1 above a certain threshold generally, and where obviously budget allows. Next slide, please, Nadia. All right, color rendering index. This is a metric where we measure the colors against 8 standard test samples to reproduce colors as you would see it in natural daylight. This is, I think, is quite a nice image of some gentlemen playing cricket underneath I'm assuming a high pressure sodium lamp, which is a very terrible color rendering index, somewhere in the range of 25%, and we generally want nothing lower than 70% or higher in order to be able to clearly distinguish or better distinguish colors as they would actually appear under natural daylight, which is around the 4,000 Kelvin color temperature, correlated color temperature. Next slide, please, Nadia. This is a video that marketing have added just to try and more clearly explain it. I'm going to mute myself for the next 2 minutes.
So just a quick note to say that if you're interested to view more of these kinds of knowledge bite videos, they are available on our YouTube channel.
Thank you so much, Nadia. Yeah, if you can bring up all the points, thanks very much. So good color rendering or high CRI provides differentiation between team colors for players, officials and spectators, and I think it also really lends itself to the enjoyment of the spectator supporting their team, as well as the team member trying to beat the other team. It helps provide good contrast between the object in play and its background, and then it provides natural appearance of skin tones. It's quite simple. It's as simple as that. And then the final slide for my part in this presentation. If you go on to the next slide, please, Nadia. Is just some examples, as I mentioned earlier, but please look out for the Petersburg installation later in the presentation, where you'll see a design that was done for 100 lux average with very good uniformities and a very low glare. All right, so there you can see the types of the examples. You can see that BEKA and Petanque, the requirement there is 50 lux average illuminance with a 50% overall uniformity. Generally, uniformity, if it's only mentioned once, it would be for the overall uniformity and not for the minimum to maximum ratio. It's quite a low illuminance value, but to try and provide you with a visual interpretation of what that means, if you look at an airport apron, if you've ever stood at OR Tambo at night looking at the apron where the planes have passengers embark and disembark, if you look outside the window, that's designed to achieve 20 lux average horizontally and vertically, but that I think gives you a good understanding. It's quite bright. You're more than capable to see clearly where you're going, distinguish colors. So that's just trying to assist in what 50 lux might mean. Football, 75 lux for practice. Sorry, let me just touch on those points. The first sport, BEKA and petanque, it's a slow game. There's very low risk for injury to anyone there, unless you have, I guess, someone throwing the balls, which is silly. All right, football. You obviously have people running at each other, playing, kicking a ball potentially at fast speeds. It becomes a projectile, it becomes a higher risk for injury. The lux level, the average lux level that you see there in Illuminous is 75 lux. That's akin to training. So in that environment, just looking at those numbers, you can expect that no one's going to be running at each other at full pace, trying to win a game. Again, 50% overall uniformity. Tennis, you can see 200 lux average. It's a very fast game. You can see the 200 kilometers per hour service, probably more now these days with the caliber of players. It's a small ball, high risk of injury, and again also taking into account the dynamic movement of the players going left to right, forward and back. They need to be able to see clearly where they're going. And then finally, horse racing. That's a 50 lux. The vertical illuminance at that is 1,000 lux for photo finish equipment and officials. That'll be your television and your camera. But 50 lux on the track generally is more than enough. Uniformity, not so much. Very important for anything to do with equine sports is shadow. There should be no shadow at all. In fact, we try to get rid of anything that might cause shadow. And if there is an object, let's say in show jumping, where they need to, there's an obstruction which the horse needs to navigate, we need to make sure that there's, again, little to no shadow in or around those objects. And that is it from me. I hope it's been beneficial. I look forward to your questions at the end of this presentation. Please enjoy the rest of this presentation. Thank you. Bye.
Right, then we get to the exciting part, the installation phase. For me personally, it's always exciting when the lights are delivered to site and the contractor can start with the installation. So basically the luminaires will be supplied to the contractor according to the lighting study, and as Retief mentioned, there are different beam spreads that are used when doing their designs. So it is important to take care when these floodlights are installed to make sure the correct beam angles are placed in the correct position on the head frame of the mast. Otherwise you would end up not meeting the results of the design. In this slide is a typical example of floodlights fitted on a high mast head frame, each in the designated position. Okay, next slide, Nadia. Right, this is just a short video where a mast with the luminaires fitted is raised and placed onto the foundations. You will also note here that in this particular instance we had to lift the mast over trees and cricket nets, and we had to basically use a larger or a bigger crane. So it's always good to take note when you do the investigation for a specific project that, you know, are there any obstructions in the way. Right, then we get to the aiming of the floodlights. So to aim the floodlights, we use the aiming device, as you can see there in the slide. That basically clips onto the back of the floodlight. Each floodlight is then aimed to a specific point on the field as per the lighting study or design. Each floodlight has its own XY coordinates where we will then aim those floodlights to. Okay, next slide. So when installation has been completed, we can then start with the aiming of the floodlights, and then to aim the floodlights, a grid is laid out onto the field with each floodlight's unique X and Y coordinates. The contractor then will aim each floodlight to its unique coordinate or coordinates on the field by using the aiming device. Right, next slide. Then we get to the commissioning, the light readings and report. Once the floodlights are aimed, we start with the light readings. Once again, a measurement grid is laid onto the field based on the lighting design parameters. It might be a 5x5 grid or a 10x10 or 15x15, all depends on the design. Where we then will take the horizontal illuminance at each point with a calibrated light meter at ground level. If it's specified that it must be at 1 meter, then we'll do so, but normally we take the readings at pitch level. For televised designs, as Retief explained as well, measurements will then be, vertical measurements will be then required as well. So that takes a bit more time, but it's necessary. Once we have all the readings captured, the results are then compared to the lighting study, whereafter a report is compiled. Yeah, and then for luminaire controls, we have a Schréder Itera available. It's a technology that Dani van der Nest will now explain a bit more. Thank you.
Hi, thanks, Rian. Morning, everyone. Yeah, as Rian mentioned, our lighting control solution for sports lighting, indoor and outdoor, we call it Itera. It is a in-house developed application which we have partnered with external stakeholders. The next is just a short video just giving you an overview of what the system is. Yeah, very short video, but I will go into a little bit more detail now. You know, why is control systems important for ourselves? Obviously, with sports lighting, we want to ensure that the right light is exactly where and when it's required as per our design. So with a control system, we are giving you the access of lighting control and the ease of configuration. We obviously want to reduce cost and energy consumption by dimming the luminaires and you know, limit the risk of your controlling of your assets. Obviously, reducing environmental impact and carbon savings as well. And to avoid rewiring of your cables, you know, in case of retrofitting, because this is a wireless featured application. Next, Nadia. This is a schematic of the layout of such a concept, and our concept is the Itera nodes, which is Bluetooth capable. It's master controllers at each point of luminaire. So depending on the amount of luminaires per mast or on a specific structure, you know, we determine how many of these nodes are required. These nodes are then wired directly to luminaires through DALI cable. But there are no other cables between masts, and therefore, you know, you save on those additional costs. We have the application on a smart device, which then speaks to this Bluetooth network, but also an offering of a physical press button control switch, which also then speaks Bluetooth to this network. This push button is as a magnetic backing to a wall-mounted bracket, which can be placed in close proximity and can be used close to the network. Next, Nadia. So this these nodes form a mesh network. So each of the nodes connects to as many possible nodes in close proximity, depending on distance and range. It is secure and self-healing in this network. So if one node is not capable of communicating, it finds the closest next to it and sends the signal over. And within this network, it's our Bluetooth 4.0 protocol, which I will show a little bit later as well. And it's capable of communicating up to 100 meters between two specific nodes. Next, Nadia. So what is the system capable of? Starting off with a dedicated Schréder app. On your smart device, we are able to dim then the luminaires. We can also group luminaires in specific areas or location. Obviously, we are creating scenes to enable the dimming. Some of these scenes are of basic animation. Why basic? Because obviously DALI has limitations in what animation is. It is not DMX, but definitely capable of certain animation scenes. Scheduling is currently available through timers on the application, and it needs to be updated through syncing on the local Bluetooth network. Future, in the very, very near future, at the end of the month, through our gateway system, an upgrade to the application scheduling will also be available in sending out notifications to the user either through an SMS or a probable email. Image control, so on the application there is specific imagery which we can then place controls on, and then physical control either through the push of buttons on the application, but also the physical press switch which we can offer in this section. Thanks, Nadia. So just some of the benefits in such an application, and specifically Itera. Ours is 100% wireless, so no cables between poles, as I mentioned. No additional controls needed into it, and also perfect for retrofitting your project for the future. It's plug and play. So once installed and programmed, there is no external commissioning required. It obviously forms a mesh network, which gives access to the scheme and multi-master capabilities between the nodes. We use open technologies and standards, so nothing different from what normal Bluetooth applications do. So Bluetooth 4.0 at this stage. Controlling between the floodlights and the master controllers are DALI 2 protocols, so backward compatible as well. And we ensure this capability and project investment over future time, because we maintain these technologies ourselves. Outstanding user experience, yes, because never before was it available to control especially outdoor sports lights through a smart device. So it's a very nice visual interface for the user as well, through all the scenes that we are capable of programming. Multi-users through different rights that we give on the application, so admin rights or just plain user rights to certain people, and also users with only visual rights, which has no capability of controlling. And it's also versatile, like I said, with pre-configured scenes, you know, just touch and go. Future-proof, why? Because, you know, you can expand at any time, adding luminaires where the capacity is available, and also with additional nodes to the application, with to the network, without any extreme, how can I put it, programming as such. You know, just adding nodes to a network is really easy. So we have the firmware through our development team, and these firmwares are updated through the nodes once your app is registered on the cloud. So it receives the firmware update, and through authentication, firmware is pushed to the nodes. And again, like I said, adding nodes in the future is really easy. We use a standard NEMA socket receptacle, and therefore, you know, future development on the same platform. Also cost effective, you know, we try to save you money. Additional wires, like I mentioned, between poles and ducting and screening isn't necessary. Additional energy savings of your luminaires, and also the lifespan of the luminaires. And again, you know, trying to reduce your installation costs. Next, Nadia. So the hardware of the system, like I mentioned, are these master controllers, our iTerra node on a NEMA receptacle, which we then place inside an IP-rated box. So from the box, the wiring then goes to the luminaires. We also then offer this iTerra Express, which is a press button Bluetooth control system. Next, Nadia. What is the software then? iTerra is a free application through the Apple iStore and Google Play stores. Once you've downloaded the app on your smart device, you need to agree to certain terms and conditions available on the main screen. Then you will continue to the application main screen, which shows you your networks. If not pre-configured, no networks will be visible, and the nearby devices, which has not been configured to a network. And then there's also a show demo, and the next few screens shows what you know, just the system is capable of. Obviously, the third screen shows the different nodes and you know, pre-configured luminaires that is part of that node. The other screen on the right there shows then the imagery. Like I said, we can take photos of your area and field, place it in this imagery, and also these white dots are then the scene control that you can click on, which will then show you just a better visualization of your area and which part of it you are controlling. Next, Nadia. The second screen there shows the scene control, which we then program with these different buttons and icons. We can also change color on these icons to make it a bit more visually pleasing. And we can also name these scenes to any convention or system that you require. The other screen shows what the menu looks like, setting up the timers, your switches, sensors, and then there's the gateway. And the last screen just shows where the Itera switch is then being programmed. Thanks, Nadia. Next. Obviously, there must be security and always a concern for any user. This security is of no different standard than the normal applications between Bluetooth control systems, which is a 128-bit shared encryption. Between the application and firmware, there is certain authentication required before it happens. And then between controller and controller, we have 40-bit encryption, which is merely impossible to hack. And also part of the application, we are able to secure the system itself where no one can see the network. We also switch off the nodes visibility, so it's only visible to these encryptions within the network. So no one with a smart device can then sit in the pavilion or close vicinity and actually see the nodes on a Bluetooth connection. And then device validation is required, with these firmware updates before it can happen. Thank you, Nadia. Next. Just to mention, if you want more data on these encryptions and which we adhere to, it is available on our data sheets, which I can share with you if required. The next is just another video, to show you Itera in action in one of our applications. Thank you. So that was a video of a very prestigious and the largest application installation to date in Kinshasa, the DRC, which was a FIFA required application, and we are very proud of that very successful installation and program. Use of Itera, as you've seen there, me standing there in the middle of the field and dimming and going through scenes of the installation luminaires. The next few slides is just references. This is one of the latest local installations we've done at Laerskool Garsfontein. Also a very successful installation, not only with floodlights, but also with Itera control. And also we are in the process of installing an indoor system for them with the same application in their main hall. So yes, I'm very proud of this installation as well. And Nadia will go through the next few slides of some of our prestigious floodlight installations. as we go through the slides, let me just mention, you see a lot of outdoor installations here, and all capable of control. But like I mentioned, we also offer exactly the same with different types of nodes in indoor areas as well.
I just also want to mention, if it's all right, this is the installation I mentioned earlier during my section or my part of the presentation. This is the installed 100 lux design with really good uniformities, very, very low glare. So I think if you can keep this in mind, I think you'll always have a good understanding, at least visually interpreted, of what 100 lux installation could look like. Thanks.
Yes, again, we're very proud of not only our flood design and installations, but also the fact that we now can control it through a smart device, never seen before in especially sport door applications. So, a great wow factor for clients to have this capability of controlling luminaires at such large numbers as well. So if required, I can email you with more detail of the control system itself. This was just a quick overview, and also more detail of how we do the physical wiring and more so between the control and luminaires itself. Thank you very much.
Okay, it's time for our Q&A session. So if you would like to type your question, please keep them short and to the point in the chat. Otherwise, you're also more than welcome to use the raise hand function, and then I think you can unmute yourself when we call your name so that you can ask your question. So please fire away.
Nadia, I think let me start with Mr. Kurt Maritz's question first up, and then we can just filter through it. I know there was a little bit of debate and answering there already, but let's just shoot through it. Retief, if you don't mind just answering this one. For one-for-one floodlight replacements on a mast or pole, we prefer fitting with a smaller rake angle to keep wind load down. However, because the fitting is now facing almost downwards, how do you prevent it from shining into the back of the fitting below it? Do you, for instance, use a fitting with an asymmetrical beam, or increase the rake angle and use the symmetrical beam angle?
Okay.
You're welcome also to look at the chat, Retief, if that was a bit long for you. Just you're welcome. If you click on the chat, you'll be able to read it there. I'm not sure if you got it.
All right. No, thanks. I think it's a very valid question, and something that we come up against a lot, specifically with existing installations, not so much new installations, where we have the benefit of the mast manufacturer being able to create a new head frame. So I agree, where you can have a asymmetrical projector or floodlight, where, as I mentioned, I think it was reasonably early in my presentation, there's two types of beam that we generally use in sports lighting, and one is collimated and the other is asymmetric, exactly as Mr. Moritz mentioned. So by keeping the rake angle low, where the peak intensity is high relative to the horizontal and the vertical plane, you can reduce the windage. So that's a possibility. But then in the chat, I see, how do you prevent it from shining into the back of the fitting below? Well, if we have the freedom, or if we know that there's the option for, I don't know, modification to the head frame, then we could potentially start looking at placing luminaires a bit higher relative to the luminaires below, and also at an angle, a head frame angle. If the head frame, this is the worst case scenario, if the head frame is set and we are only allowed to place luminaires on the existing structure, we have to provide the best solution possible. However, it's not always possible then, in that instance, to not have flux being emitted into the back of the luminaire below. What we do in the design stage is to then simulate that head frame. If that information has been presented to us, we then create a design where the luminaires are positioned exactly as it will be installed in reality, and then we base our results on that installation, and we generally get a good workaround. We generally still achieve really good uniformities. We would never send out a project, excuse me, we'd never send out a design that doesn't comply to the briefing, or at least having explained to the end client that these are hurdles that are being faced. We need to potentially, it opens a door for discussion. So I think, to summarize what I'm saying on what my answer is on this question is, I agree on getting a smaller windage area if it's possible, to reduce the size of the luminaire and maintain low rake angles. Yes, I agree with that. In events where where you have no option and you've got to do what you can with what you have, but still provide the client with the requirement they've asked for, we really endeavor to do that and maintain a good discussion around it, an open dialogue, so as to then at least move forward. And I think that's it. Where we can use symmetrical beams, collimators, we will, where it's necessary. Let me just expand on that as well. Where you use a collimator, you're getting much more flux onto the field in a quicker fashion, so you're potentially going to have fewer luminaires. The benefit of the asymmetrical optic is obviously first the low rake angle, and also the distribution in the horizontal plane, so you're getting good uniformities. And it's always this kind of give and take. Maybe use a collimator on the sides of the mast, of the head frame, and then raked asymmetrical beams in the center of the head frame. And these are things that we do consider. But I hope that's answered the question. I think it's a very good and relevant question. Thank you.
Thanks, Tiff. Then after that, Mr. Björn Smit-Hart was referring to, should we refer South African sporting facilities, or should lighting standards be referred to any South African sporting facilities, and SAN standards to references? So that was really the question around how we should adopt any standards.
Okay, so hold on. So what lighting standards should we refer to for South African sporting facilities? Any SAN standards? There are no South African national standards for sports lighting. We have the recommendation of the old Sankey document. Generally, we would work towards the relevant authority on the type of sport being played. We have had a meeting with Supersport. I think it was now 3 or 4 years ago. You can correct me, Grant, where I'm wrong, but if it's a Supersport type installation, we follow their recommendations. But again, I think it is something that should be discussed at IESA level. Is a South African national standard, or a recommendation at least, for sports lighting, because not everyone knows. There are clients who don't necessarily refer to specific authorities on specific sports, but rather just say, please give me 300 lux for this area, carry on, which can become very vague and have its own kind of problems. So I hope that's answered that question.
Thanks, Tiff. And then Mr. Kurt Maritz again referred to, I think it was more of a statement. We see many requests for one replacements for sport lighting. However, trying not to exceed the existing wind load is always a dilemma. Hence my request for smaller rake angle, which helps to keep the fittings wind load down.
yeah, I can simply agree with that statement. I think it's a valid statement. We have, in my opinion, the best R&D department in Africa, and with regards to lighting and development of our luminaires. We have a really good team abroad. So yeah, these are things to take into consideration. So yeah, wind load is an issue. There's always, if it's an existing mast, you need to take into account the structural integrity of the mast and the wind load. You can always go and figure out what the mast was designed to carry. If you go look at a typical 2 kilowatt luminaire, you're in the region of about 35 kilograms for a luminaire. And then as long as we can maintain, I mean, it's very easy for us to compete with a 2 kilowatt double-ended metal halide lamp on flux and efficacy, especially in our OMNIBLAST-E Maxi, which is actually about, what was it, 17 or 14, 17% more, provides 17% more flux than the current 2 kilowatt metal halide lamps at 2,112 watts. So 1-to-1, the 3 Maxi will beat any 2 kilowatt luminaire every day and twice on Sunday, but weight-wise, it's a different thing. And I think the relevant investigations need to be done.
Thanks, Retief. Then Mr. John Fox with a question for Rian with regarding to the calibration of the aiming device. I'm sure, Rian, you had a read there if you want to answer that one.
Yes, John, I don't know, is there something specific you want to ask?
Yes, so let's take a symmetrical fitting. Obviously your telescope and the reticle within the telescope, as well as the laser diode in your red dot or whatever, is obviously mounted at a different or in a different plane to the light's photometry. So if you take a symmetrical fitting and let's say the point of impact of that fitting at, let's say, 30 meters, is going to hit the field at a specific point. Obviously, because that scope is not in the exact same plane as that point of impact, it is an offset. That reticle is obviously adjusted in terms of elevation and windage to match that point of impact. Similarly, the laser as well. But as soon as I then move it to a next fitting that is now aimed at, let's say, 50 meters, that calibration and adjustment to match the fitting aimed at 30 meters is now going to be off, because you are trying to get the reticle and the laser and the light's point of impact to intersect at the same point at that distance. But if you then amend or change that point of impact distance, then the reticle and the laser aren't going to intersect at that point of impact anymore. So obviously that will affect your aiming or your aiming accuracy and then ultimately your light distribution. So how do you guys calibrate that reticle and laser, and at what distance do you use to get like a ballpark average, so that if I aim my fitting using that reticle and laser, that it kind of covers your let's say 60% average of the fittings that's being aimed?
Yes, yeah. Jono, what we find in practice out there, that if we calibrate the scope with the laser at around 40 to 45 meters, it's quite accurate and can be used in all around for the floodlights that's close and the ones that are aimed a bit further. But I know exactly what you talked about. We experienced the same, and we had to basically look at it and see, what is a good median, and we find that between 40 and 45 meters, it's a good distance to calibrate it to.
Okay, so and then that calibration is I presume done from, or how do you reference the? So you just take it on a flat horizontal plane, let's say in a warehouse, and you put it down and make sure that the scope and the laser is horizontally and vertically plumb, and then you shoot the laser at a 45-meter target, and then bring the reticle across as well. Or
that's
how,
correct.
how do you
Yes.
kind of? Okay, so but
Yeah, that's exactly how we do it. Yeah.
okay. Okay, now cool. Thank you.
Excellent.
Thank you. There were some comments from Bjorn Smith-Hart with regards to the rake angles. It was agreeing with Kurt. The rake angle can help provide that the optic, provided that the optic be selected to offset the effects of the lower rake angle, selecting an optic to yield similar lighting levels, distribution, etc. Yeah, just with regards to the recording, that will be distributed, a link for that, so you don't have to worry about that. There was, thank you, Curtis, for just giving a brief overview of some of the standards that we do use. I think everybody across the board, depending on the application and light level requirements and specific sport application, we adhere to all different standards depending on the customer's needs. Let's see, yeah. Bjorn Smith-Hart, I don't know if you'd like to just specifically comment any more on that with regards to your answer to Kurt, or are you happy that we carry on with the general questions there? He's still online. So please, if there's any other questions, you're welcome to raise your hand and ask away. Doesn't seem to be any more.
I have one. What's the difference between a good and a bad joke? Timing. Thanks.
Thanks for the bad joke, Retief. I don't see any other specific hands up or questions. This last quick round, if anybody would like to ask something, please, no matter what it is, you're welcome to. Oh, we do have one
Sure.
there.
Let me throw another one into the mix to Mr.
Yeah,
Kutzer
please.
there. And it relates also to the one-on-one replacement or rake angles and asymmetrical fittings and all of that jazz. I think there was actually, or what we're kind of referring to in terms of mounting, with your Omni fittings, because of the stirrup design, if you have a head frame, new or old, where the cross arms are all in the same plane, I think you'll be hard pressed to not backlight the fitting or the fittings below. And I think actually one of your slides, 2 or 3 pictures back, actually indicate that, where you can see the back of the fitting is being lit up. So, or okay, let's say even if the cross arms are in the same plane, they must obviously be vertically spaced adequately or to an adequate distance apart, so that you can avoid that backlighting and obviously losing that light that could have been on the field of play, lighting up the fitting below it. So obviously that becomes quite a bit of a point of or not a point of contention, but a problematic workaround when you do one-on-one replacements, obviously given that the wind load or that the mast can handle that one-on-one replacement. So is there a possibility that you guys can look at potentially, although you have a standard stirrup, if the vertical distance between the cross arms is not great enough to avoid that backlighting effect, is there a possibility that you guys can potentially work on an alternative stirrup or an offset stirrup so that the fitting at the top can be extended further past the one below it or something to that effect?
Hello, Mr. Fox. Yes, nice to meet you. Cool surname. I just want to say I think it's a very valid point that you're making. R&D are actually in the process of coming up with a very great new stirrup. So your comments are absolutely relevant and valid. Just to mention where installations are existing and we're limited by the existing head frame and we have existing cross arms, we try to only take into account the smaller windage 2E midi or 2E maxi. We try to stay with the 2E midi, but where necessary we go to the 2E maxi. and to negate that kind of intrusive flux on the back of the luminaires below, where the cross arms, as you say, are basically horizontally in the same plane and then vertically above each other in the same plane. So there's no rake to the head frame. So I understand your query. You make a relevant answer, and we are in the process, in fact, of developing a new stirrup. I hope that answered that question.
No, absolutely. Maybe while we're busy, while the R&D is busy, just before they build it, maybe just have them, and I see Kurt also dropped the same question. Maybe also if they can look at the underslinging as well, because I know the Omnis, if you look at a typical existent head frame that's maybe underslung with your current Stadia Lux fitting. So if you go your Omni in there, then underslinging it's gonna causes a bit of an issue.
You'll see Mr. Pieter van Aert just commented on that. He's also sitting in on this webinar, and that is part of the R&D solution they're coming up with now, is for the underslung capability as well.
Fantastic, thanks.
No worries.
Yeah, and I think also attached to that, what's important is the pre-sales aspect to this. So really consulting at the level so you don't have these issues at installation phase. So no, thanks, John, for your questions. Anybody else with any comment, statement?
There's
question?
a hand raised. There's a hand raised, Godwin Locher.
Okay.
Hi, do I have the floor?
There we go.
Yes.
Yes, you do.
My question has to do with the arterial system. Now, is there any possibility that you can have an override switch to choose between the arterial system and the manual push button system? And if that's the case, how do you do the reticulation?
An override switch, sir. I need to understand why an override switch. So because it's Bluetooth, you need to be close to the network. It's not remote, so you can't access anything without being close to the network. So relevant to what you want to use, either the hard press switch, which is then part of that network setup. If you're close by, it will work. If you're far away from the network, it won't work. And the same with the application.
Yes, I agree with you 100%. Recently, Ratif and I and Adrian, we've just done some design on a project and a stadium project, and the client is requesting that in addition to the arterial remote system, they want to have a manual push switch system as well. So they want to have both the arterial and the push button system, the old system. How do we, combine the two?
Look, with a bit more delicate thinking. In general, I would say that it's two different systems and that it won't interfere with each other. Like I say, the Bluetooth is set up with the nodes. As long as the nodes are active, you are able to control it with the Bluetooth system. If the nodes are switched off, then obviously there is no access of control through the nodes. However, then a hardwired system would then be required in parallel to this, where you would need to hardwire the dolly from the control gear of the luminaire right down to the bottom of the mast and to the kiosk, or to where the physical switching of these momentary switches sit. And with these switches, you will either, if it's not through main switching, if it's part of control switching with dolly, then you obviously need a different controller on the bottom. We offer both. Just to be clear, we can offer a hardwired system of dolly, but here we've just mentioned our wireless system through Bluetooth. Definitely possible with both, but there's a few other considerations we need to look at in this project.
Okay, all right, okay, perfect.
Hope that helps. Thank you.
Okay, anybody else? statement, comment, you're welcome to raise your hand. We'll just give it a few more seconds. Just from my side, a big thank you to all the presenters. Just quickly while we're all together, and then I don't see anything more. So Nadia, I'm going to hand over back to you.
Thank you. Okay, so just again, as mentioned just now, actually, that you will be receiving an email early next week, which will contain a link to this recording. And it's also available on YouTube if you want to go there direct and just also have a look at all our other videos that are available there. So we also encourage you to visit our website or to get in touch with the relevant branch should you require more information. And so, yeah, a big thank you from us. Thanks for joining us.